All right, welcome to Science, everybody. Next part. And my son just told me he has no idea what I'm talking about. Hopefully you guys do. All right, here's another very minor new thing. This right here. ESRT, page 1. Now, these questions used to be a lot harder on the older version of the Regents. They stripped them down so that they're so easy that my theory is, and I tested this once, that you could answer this even if you didn't speak English. Because all they'll ever ask is gained or released. So why don't we take a second and underline those? Or maybe I'll just box in these. They'll say, is energy gained or released? Then they'll ask the amount. Is it 334 or is it 2260 joules per gram? And again, that joules per gram thing is not a big deal at all. It's just a unit. How much energy does it take for each gram? Does it take to either melt, freeze, vaporize, which is like boiling, or condense, which is the opposite, which is going from a gas to a liquid for water? I saw one question recently where they made you do it with 2 grams, which would just mean you take this number and double it, but I won't be that mean because it's new. All there will be, and there will be one of them, is match the words. Released, freezing is 334. Gained, vaporizing, 2260. That's it. So again, I think if you, and what I did to test this was I gave the students a question that was like that, and there's different language versions of the Regents. And people got it because it's just matching words, even if you don't know what those words mean. Okay, so pretty easy stuff, which is why I didn't make a big deal of it. When it comes to the to that question on the test, pop open that reference table, page 1. This exact chart is there, and match the words and the number, and you got yourself a couple points. Easy, easy, easy. Specific heat has a few more conceptual things, so let's talk about that. There's no, you won't have to think with any of that. This top one is all just match words. This one, maybe a little bit of thinking. So what is specific heat? If we remember, and it's kind of indicated by the label here, joules per gram times degrees C. It's how much energy is needed to heat a substance. Where this chart is mostly of value for this unit, for what we're doing in earth science, is the idea that water up here is very high. Water is a very high specific heats, which has all the implications that went with that temperature range lab and that temperature lag lab. That water, since it has a very high specific heats, what that means is that it takes a lot of energy, and we'll move that, to heat water. And I guess we should also mention then the other way to think about that is that water heats and cools slowly. And I know that feels weird because you probably boil water all the time. I just did it to make some coffee. It's a very commonplace thing. So it's bizarre to think about the idea that it takes more energy than all this other stuff that you'd never deal with. When's the last time that you had to heat some granite? You know what I mean? It's not something that you're used to. So, but even though you do it all the time, it's still, this is the idea. It takes a lot of, sorry, my mic keeps cutting out for some reason. It takes a lot of energy to get it to warm up. Therefore, it heats and cools very slowly. So the implications with that, if you didn't do the temperature range lab, yes, it would be a good idea to do it before Friday. If not, this concept will be on the test. Here's the big idea. If you live near an ocean, which would be this blue line, I'm going to blow it up a little bit, but not that much. If you live near an ocean, because water takes a long time to heat up, you don't get as hot in the summertime. But then flip it over to winter, and you don't get as cold either because the ocean holds onto that energy and cools off very slowly. Versus if you live in the middle of the continent, and I shared living in Minnesota for this, you're very far from any major bodies of water, and it got very hot in the summers and very cold in the winters. What we call a large temperature range, the difference from low to high, was the most significant. And the further you get, the relationship, which we should be getting better at relationship questions, the relationship is, as you get further and further and further from major bodies of water, the temperature range will increase. Large bodies of water moderate your temperature range. We do get this to a smaller effect at Lake Ontario. Lake Ontario, 800 feet deep, it's a lot of water in that thing. So Lake Ontario will keep us, if we're very close to the lake, will keep us a little bit cooler during the summer. And then it is like a heat battery. It spent all summer slowly building up its heat. And now look what happened outside. It's snowy and frozen out there. The land, the air, everything cooled off very quickly down below freezing. The water can't cool off that quickly. The water's still holding on to that heat. And that heat then radiates back out to the land and keeps us a little bit warmer than it would if you were even 10, 15, 20 miles away from the lake. Okay. That really is the whole thing with the specific heat. There's occasionally questions that will be like, give me a specific number. If that's the case, look it up, give me the number, right? Conceptually, though, this stuff with water is really where it's at. So let's talk about land breeze and sea breeze quick, and how this works. So if the sun's out during the day, and I guess this is kind of new, but you've seen basically this idea because you did this land versus water lab. You heated up sand and water under equal amounts of energy. Which one heated up more? The sand did. The sand should have. So during the day, and if you've been to the beach, you know this. Your feet get hot in the sand, but not in the water. During the day, it gets hot here. Therefore, warm air rises. What that does then is create this convection cell in the atmosphere, blowing cool air to shore. Whereas at night, it can flop. And I'm not saying this is every day. If there's like a major weather system pulling through, that's going to take over this small effect. But it's a small effect on days where it's quiet. At night, since the land can drop off more, the sinking starts over here. Since the ocean is, or even the Lake Ontario, this works on Lake Ontario, will be warmer. The air rises over here, and you get the opposite convection cell, a land breeze, which blows offshore. All right. So yeah, again, it all boils down to just the sand versus water lab. Which one heats and cools faster? Sand. And the why is because the water has a high specific heat. That's probably kind of the most intense, heady stuff that we'll have on this test. And you'll see it on the practice questions. And hopefully do a good job. Rewatch this video a couple times if you need to. Get ready. And again, if you didn't do this lab, maybe we should write a quick blurb here. If you didn't finish this lab yet, while it may not be a bad idea to finish, I think finishing the test review stuff is probably more important. So as distance from an ocean increases, temperature range increases. Further you are from an ocean, the bigger your temperature range will be. All right, good work. Almost there, folks.